Okay.
So it is really a great pleasure to have here with us Dr. Mohan, giving a distinguished lecture, giving a talk as a part of the distinguished lecture series of the Department of Computer Science at the University of Crete on AI, past, present, and future. Dr. Mohan is a retired IBM fellow. He has been a researcher at IBM Research US for a long time. He has a very long CV with a lot of prizes and distinctions.
Don't take too much time.
No, but I would like to just mention a few things. He's currently a distinguished visiting professor at Tsinghua University in China, a consultant to Microsoft Data Team, and an advisor of the Kerala Blockchain Academy in India. He retired in June 2020 from being an IBM fellow at the IBM Almaden Research Center in Silicon Valley. And he has been an IBM researcher for about 39 years in the database, blockchain, AI, and related areas. And his research had a big impact on several IBM and non-IBM products, also in the research and academic communities and standards. And also his invention of the well-known Aries family of database locking and recovery algorithms had also a significant impact. He has a lot of prizes and best paper awards, like the VLDB 10-year best paper award in '99, the ACM Sigmund Edgar Code Innovations Award in '96, and several others in IBM. He has been elected to the US and Indian National Academies of Engineering and has been named an IBM Master Inventor. He did his PhD at the University of Texas at Austin, and he has been a distinguished alumni of IIT Madras. He is also an inventor of 50 patents, and he has served on several advisory boards. So it is really great to have this opportunity to hear his talk on AI. So thank you very much for being here and spending this time to give us a talk and discuss with us. Before giving the floor to you, I would just like to say that this specific lecture is going to be recorded. And if somebody wants to, so every participant agrees, gives the consent to be a part of this presentation. But of course, you're welcome to turn off your video. And I would like actually to ask you, if possible, to turn off the microphone during the talk. After that, a question and answer session is going to follow, and you are most welcome to raise your questions to Dr. Mohan. So thank you all of you for being here, participating in this talk. And Dr. Mohan, the floor is yours. Thank you very much for being here.
Thank you, Maria. Really appreciate your taking the trouble to host me and go through some of the, pain of getting things organized at the last minute and all that. And with all your travel,
just pleasure.
You just came back.
No worries.
And as I was saying before the formal presentation starts, I've been here in 4th. I'm physically sitting in 4th right now, a few offices from where Maria is. And this is my second visit to 4th itself. First was long time ago in September '98. And I've been to Crete. This is my 4th visit. And last time I gave the talk at the University of Crete, hosted by Christos Nicolaou, who was hosted me the first time too. So I enjoy, giving talks, and I have lots of Greek friends, especially in the database community. And so let me see, it's saying something. Who can share? Only host all participants. Why is that thing coming up when I'm trying to share? Only host all participants, okay. Who can start sharing? I don't know why it's asking me all these things. Okay, I really want to share. This will stop other screen sharing. Yes. Okay. All right. This presentation, I've given it a few times. I don't claim to be an AI expert or any such thing. It's just that over a long period of time, given my age and all that, I've been observing what goes on in the world. And so even before I came to America to do my PhD back in 1977, I was already aware of some of the AI work going on in the US and other places. And so some of this knowledge I've retained, and so I'll refer back to some of that. So this, okay, okay, this is the slide. So if you want to get hold of the slide deck, the link is there and also the QR code. What you'll observe is that the slide deck has more slides than what I'm going to show. So if you download the PowerPoint, which is what is at that URL, you will be able to see only the slides I'm going to show by going into full screen mode in slideshow mode. But if you go into edit mode, you'll be able to see some of the hidden slides, which contain a lot of information. You'll see a lot of links to information from across the globe. The point of this presentation is not so much to go, deeply into any particular algorithm or go crazy with one idea and things like that, but to give a much broader perspective, especially coming from an industry guy. I was at IBM for almost 39 years, and also focus on stuff that's not just fad kind of topics, but really practically useful things. So it's in that context that you should view my presentation. A longer version of this presentation I actually gave a few months ago, and you see here the slides as well as the video link. This was done remotely when I was in Singapore as the visiting professor at NUS, and it was sponsored by Tsinghua University in Beijing. So you might, if you get excited about some things I have to say, you might find a lot more explanations and more material being covered in that longer presentation. So as everybody knows, there's a lot of hype and there's all sorts of tall claims being made about what is possible with AI. So this excellent presentation by Arvind Narayanan of Princeton points out, why there is so much AI snake oil, and then he tries to, point out all the silly things that some people claim, especially some people who want to make money quickly and things like that. They even say things like, oh, while interviewing a person, by analyzing the person's facial expression, this algorithm can predict whether or not this person will be a good employee and so on. A lot of bogus claims are made. And so you have to be very careful in the real world to, not think that just because somebody says their system has AI, that somehow it's far superior compared to some other system that doesn't say anything about AI. So this AI label is being slapped on all sorts of things just to make it look sexy or make it more attractive for potential adopters of the technology and things like that. The other thing to keep in mind is there's way too much hype also coming from academics as well as certain kinds of industry people, where they try to equate AI to basically deep learning. And they think that just because the Web 2.0 companies, social media companies, or e-commerce companies who have incredible amounts of data, and hence they are able to do certain things by developing machine learning algorithms, they make it appear as if this is the most common story with respect to all sorts of organizations. But in fact, you have many different kinds of organizations in the world, and they differ in many ways, including the size of the organization, the amount of data that they have about what the main business of the organization is, or their customers or clients and so on. And some of these are B2B or B2C, or people to people, government to government, government to people, and so on. And they may be for-profit companies or NGOs and things like that. And in a lot of these cases, they don't have the kind of data that has conveniently been assumed to exist by people who promote some of the newbie, or at least currently in favor kind of technologies like deep learning. And so the business models also vary. Some people are able to blow up a lot of money in cranking out, models with trillion parameters or whatever kind of, big numbers that people throw at you. And they waste a lot of energy also in processing these models, because they're not making money directly off of that thing. They are making money, in the case of the social media companies, from advertisements. This is not the business model of your standard organization, whether it's a commercial organization or non-commercial. So that also has an impact on the amount of machinery that you can throw at the problem that you have to solve. And so keep that in mind as you look at the hyped up technologies, and understand what your situation is in whatever organization you are, whether some of these things are applicable to you or not. And so AI is not a panacea. And I just heard that the word panacea is actually a Greek word. This was something somebody mentioned yesterday. And at the core, it's still data, okay? So don't think that you can ignore database people like some of us who have spent our entire career on hardcore database technology, since data is like the new oil. And there are also many risks associated with AI, and I won't delve into each of these topics, but keep those things in mind also, whether you use AI for social good or you use it to kill people in other countries and things like that, military, also things like ripping off the public by doing deep fakes or changing the opinion of people with fake news and things like that. And the last one is the one I just talked about, which is the huge computation costs involved in some of these, god-awful models that have been developed with way too many parameters. It might be sexy for Google guys to talk about it, or some other company which has lots of money to blow up on buying machines and giving electricity to do these things, but that doesn't necessarily work for every other organization, the average organization that's out there. And also, privacy and all that have become very important. So in this context, some of you might or might not be paying attention to what's going on in certain kinds of publications, not your average research publication. If you look at MIT Technology Review or Fast Company or New York Times even, recently these sorts of articles have come out. So even companies like Google and Facebook have gotten into trouble. Even Turing Award winner LaCoon has gotten into some of the debates regarding that very first article in the top left corner, how Facebook got addicted to spreading misinformation, how they hired a guy to deal with it, and then the guy is being put through the ringer in terms of not being allowed to do the quote-unquote right thing, because that might affect the revenue potential of that company. And in a similar fashion, Google hired this African-American woman to deal with fairness issues and all that. But then when she tried to do certain things, they again didn't really let her do her thing. And so she essentially either left or was fired. And so this caused a lot of bad publicity for Google. And so keep all these things in mind as the world is trying to figure out the real life implications of this kind of technology being adopted in a widespread way, and in many ways in an indiscriminate way. So just to keep, especially the youngsters who these days equate AI to deep learning and think there is nothing more to it, this diagram tries to illustrate that there is more to AI than even if you go to the level of machine learning. And so I'll give a little bit of the history of how things went, hence the reference originally to Carnegie Mellon and speech understanding and robotics and all that happened even before I started my PhD back in 1977. It's also interesting in this context to look at the various definitions of AI that are floating around. You will see things like the link at the bottom of the slide all across this presentation. I highly suggest people go look at them, even if you are an extremely hardcore researcher type, couldn't care less about real world. There is quite a lot of information that's been put together by various organizations. And I've taken the trouble to, aggregate all that in terms of putting them together in a single presentation. So if you look through this definition carefully, you will see, there's various kinds of data involved, reasoning being done on knowledge and the processing of the information and deriving certain interesting pieces of information and then using that to trigger certain actions to happen and then seeing the effect of that. It could be, even sometimes manual actions, or it could be machine actions, robotics being involved, symbolic rules as well as numerical models. For the longest time, when originally speech understanding and such were done, it was more symbolic rules that were the basis for what actions the system took and how it, figured out when somebody speaks what the different words are, and even if there is ambiguity, how to resolve it. So they took into account, for example, syntax, semantics, and even the phonetics of the words being spoken by measuring the frequency and all that. So that was a much more domain-oriented way of doing things compared to this black box approach that's currently in high fashion, namely deep learning, originally called neural networks a couple of decades ago. There are many more things in here that I'm not referring to right now, but the US Defense Department has characterized the different waves of AI by talking about the notional intelligence scale, which has to do with the level of perception, learning, abstraction, and reasoning that these systems are capable of. And they also have a way of measuring how good they are by talking about minimal versus adequate versus nuanced and advanced. And so in doing this, in this way, they characterize what the situation was, for instance, during the three waves of AI that came about. In the case of the first wave, it was handcrafted knowledge, where people with expertise in a domain, like for instance, speech understanding or robotics, codified the rules and the knowledge in a way to then figure out if something is ambiguous, to resolve it using the semantics of the language or the syntactic structure of the language, and so on. So this was time consuming, clearly, but it actually was more powerful in certain ways than what is now in fashion, which is the statistical way of doing things. And the third wave is the one where more needs to be done in order to make the situations where the second wave is not cutting it to make it work, okay? So just to put things in perspective, here is a list of people who have won Turing Awards for their work in AI. And so it's been going on since '69. The field of AI itself, contrary to some man on the street or even young students might be thinking, is not at all new. In fact, the phrase AI was coined in this famous conference, small workshop really, in 1956. So I was a 1 year old when that phrase was cooked up in this Dartmouth conference. So John McCarthy is credited with having come up with that name, artificial intelligence. The most recent ones to get the Turing Award were the three people who get a lot of credit for the current focus on deep learning. And so it's also interesting to look at the places which have been having a lot of influence in the field of AI, Carnegie Mellon, Stanford, and more recently, even Google and Facebook and such, because some of these people who were university people now have industry affiliation also. During the first wave, engineers created sets of rules to represent knowledge. So knowledge representation was an extremely important thing. Production rule systems and such were the ways in which they codified the rules, and the AI systems were able to reason over narrowly defined problems, but they didn't have enough learning capability or poor handling of uncertainty. So, but the reasoning was pretty good. So if you go back to that scale, this is the nuanced one, not yet the fully advanced. whereas learning and abstraction were not even in the very basic minimal stage. Perception was in the minimal stage, okay? And so areas like cybersecurity, expert systems, and command centers and planning tools with respect to, logistics and such benefited from it. And if you look at the history of this, as I said, it was in '56 that the Dartmouth Summer Conference on AI was held. But even before that, there had been science fiction and Turing test and such, which all relate to the topic of AI, even though there wasn't a formal name like AI being there. And then later on, of course, you had things like, the Deep Blue system of IBM that defeated the best human in the game of chess. And later on, of course, Watson happened, which was in the context of Jeopardy. In between, Japan also had this 5th generation project, which the US thought was going to completely make the Western countries get superseded in their work and so on, in somewhat similar sense to the current fear of China taking over the world and becoming the #1 country in AI, for instance, right? So you can read more about all of these sorts of things in the links that you see here. And it's very educational for people who haven't been around a long time to go through some of this, just to see what mistakes were made in the past, what things worked, what didn't work, and so on. So some of the slides here are from Rajreddy. He gave a talk in Shanghai in November 2017, soon after the Communist Party had its once in 5-year conference, which is where they made the decision, for instance, that China will go whole hog into AI and try to outsmart the Western countries. And I'll get into that more later. But he talked about what an intelligent system is and how when you don't have a precise way of characterizing something, like a formula, like knowledge compensates lack of search, F equals ma, force equals mass times acceleration, or energy, E equals mc squared, you do exhaustive search. That's how a lot of these game playing systems work, right? Puzzles and so on, because you don't have precise rules that you can follow to actually, very quickly arrive at a solution. And then there are various sources of knowledge, formal knowledge versus informal knowledge, and how to capture those and encode them in systems so that future situations can be dealt with more effectively, and also future people can benefit from things that have been already figured out rather than each of them having to discover it themselves. And there are various ways of encoding this knowledge: expert systems, knowledge-based systems, rule-based systems. So this was all stuff happening, late into the previous century. But the other things that happened are some of the things like, long before this current interest in self-driving cars, there had been actually work where ARPA in the US had funded self-driving cars, and there was this thing called No Hands Across America. But the major difference being then they were doing only highway driving with these self-driven cars, whereas now the focus is much more on city driving, where there are many more complications. And robotics also, as I said, in CMU, Rajreddy was responsible for speech understanding, and then after that, the Robotics Institute over there. And computer vision in manufacturing and things like that were the focus. Not so much the current thing that, everybody gets excited about, recommendation systems and other optimization problems in the context of e-commerce and social media ones. Of course, there are many interesting problems in the new context, graph-based way of doing mining and things like that, right? So the second wave of AI, which is characterized as AI 2.0, the way Rajreddy described it, what he said was, in the good old days when he was working on some of the problems, he thought there were more problems to be solved, and he didn't think that those things will get solved in his lifetime. By the way, he's like 80-year-old or something. He's still very active, okay, at CMU. But he then said, actually, a lot of those problems got solved. And then he was trying to figure out what enabled that. And that's when he said that happened because of improvement in computer technology as well as software algorithms and such. And it was also because of availability of vast amounts of data. And so it's these combination of things that happened that hastened the emergence of solutions to problems that he had thought won't be accomplished before he passed on. So, but it was this event in Shanghai where I said the Chinese top brass from the government as well as the research entities and universities and the Chinese Academy of Engineering and so on, they came and gave us presentations, and they talked about how at the highest levels in the Chinese Communist Party and the government, they had decided to go whole hog into AI. And also a company like Baidu, which I used to think was in a totally different space, social media more like, was engaged in self-driving cars and such. They had developed their own operating system. And there was a fantastic talk by Shi Lu. And the major point they made was they think they have an upper hand vis-a-vis the Western countries, because the kind of data that the Chinese equivalents of Facebook, LinkedIn, Google, and also Amazon, they've collected information approximately for about 1 billion people in China, and they felt that the economic status and such of those people are very similar to the people of India, another 1 billion people, Africa, I'm not sure what the number is, and also South America. So they felt that if only they'll get their act together and expand their businesses by supporting English and other languages to expand their businesses to these other countries and continents, then they would be far better positioned, because they've dealt with the kind of people who live in small homes and who make less money and they're very cost conscious and so on, compared to the mech mansions and such that the Western people live in, and the overall lifestyle being very different in many ways, culturally and so on. So for many such reasons, they, in a very practical way, believe that they have the potential to do better than the Western countries. So it was a very revealing talk actually by Ji Lu, and you can even read his interview in the Wired magazine about all this. So of course, there are all these things that are happening where AI has become pervasive and it's affecting all aspects of society and things like that. And then there is this focus on general AI versus AI for a specific topic. So the second wave of AI, which has been fueled by statistical ways of doing learning rather than in a very handcrafted way, in a domain-specific way, is what is currently, as I said, very fashionable, and it's allowing for certain things to be done better. So if you look at this comparison, you see that in the area of perception and learning, it's doing much better than before. But in the area of reasoning, we've gone backwards. This has to do with the fact that things like explainability and all that are not there, because you are doing things in a very statistical way, and you can't look into the model and try to say why the model came out with a certain result and try to figure out why did it think that somebody doesn't have cancer or somebody does have cancer. What are the various reasons behind that conclusion? It is not able to explain it. Whereas in the rule-based way of encoding the rationale that results in a certain conclusion, you can actually look through that path that was taken through that decision tree or whatever and be able to explain it. So there are many things that have been the key enablers for the second wave of AI, and some of that is shown here. I'll let you look at some of this at your leisure. But one of the things to note is that if you look at the kilowatt for 1 billion parameter deep learning network, over time, by going from using just regular CPUs to GPUs, the power requirement has been dramatically reduced. And more recently, of course, there are other things that are being explored that I'll mention later on. And also the big data space in terms of, how much data there is out there. It's all, lots of hokey kind of estimates that are being made. It's not very precise scientific thing. From 2005 to 2020, supposedly the data has gone from 130 to 44,000 exabytes. Okay, and there are many application areas. One can spend tons of time talking about it. So the way this was arrived at, what are the areas of focus and how much activity is there, was to look at the patents that have been issued that relate to these different topics that you see in this graph here between 2004 and 2013. It's very interesting, you know, if you go beyond your paper writing and measuring each other based on where you got your paper published and try to, you know, in a more global way, look at the trends and so on, the way these things get measured is quite different from our typical industrial or academic research ways of doing things. In Stanford, there is this institute which puts out an annual report. Like many other universities, it's, you know, another one that has a focused research center on AI / analytics and such things, right? So they produce this very comprehensive report, and you have the link here. I highly suggest people go look at these things. And they looked at various aspects of what's been going on in terms of what areas PhDs are coming out in. If you now focus on AI kind of topics, right? AI and related topics. You know, where are these people coming from? What are the demographics of these people? What application areas are the focus? What are the problems like diversity challenge, and how China has overtaken the US in AI journal citations, things like that, right? But conferences are treated differently from journals and so on. And also, if foreigners come to America to do their PhDs, do they go back to their home country, or do they, you know, continue to be in the US? And, you know, minorities and what they are doing. Is there any, you know, universal consensus on what it means to talk about AI ethics? Are there benchmarks? Things of that nature. And it turns out even the US Congress has gotten into the AI game in a big way by even coming out with a law, a part of which, the defense spending law, there is a definition of AI. And I have more of that in the hidden slides that I welcome you to look at. And also the, you know, general concern about surveillance technologies, while they are useful in many ways, there are also privacy concerns about them and things like that. So this is the, you know, this whole neural network, which is now, you know, more commonly called deep learning, has been around for a long, long time. But it is something where you have different levels, but you have to sort of imagine that, you know, if you feed in a cat picture, that the different levels are doing certain aspects of figuring out whether it's a cat or not. So you first figure out for the different pixels, are they light or dark? And you then try to identify edges, which might be the, you know, boundary of an ear or whatever. And then if you look at the combination of edges, you figure out this is the eye versus this is the ear versus this is the paw and things like that. And then you try to identify even features which might be like it's got dark eyes versus blue eyes and things like that. Or it's got 2 feet versus 4 feet. And then ultimately you look at the combination of these sorts of features to conclude that, this is actually a cat picture and not a dog picture. But it's all very, you know, statistics driven rather than really looking at it in the way, for instance, in this slide, how you characterize what an apple is. The origin, the structure, the kind, and, you know, what the shape of the body. This is like the, you know, speech understanding one where I talked about syntax, semantics, and phonetics and all that, right? So this is the symbolic lens versus the top one is the neural lens. And if you look at the progression that is expected to be the one that the world needs to go through, from narrow AI to broad AI to general AI, the systems have done very well in the context of narrow AI, which are single task, single domain, whereas broad AI will be multitask, multi-domain, and you need to be able to, in broad AI, learn from small amount of data rather than vast amounts of data being the basis for narrow AI. How broad AI is more important for enterprises rather than this very narrowly scoped things in which narrow AI is okay. How explainability, robustness, and customizability and all that is extremely important for broad AI to really be accomplished. And if you need to go across domains and such, and you want to combine neuro and symbolic ways of doing things, that's what the sort of the ultimate goal, if you like, broad autonomy and so on. But if you look at this very narrow thing called the ImageNet classification problem, that's like a benchmark that way too many people are focused on as if that's the be all and end all of life. Since about 2015, the system is doing better than humans in doing recognition in terms of as measured by the number of errors that are made. So that's quite a fascinating thing. But what are some of the topics for this narrow AI? It's language translation, speech transcription, language processing, and visual recognition. So there are many of these kinds of application areas that I'm sure most of you are aware of, that have to do with object detection, face recognition, and tracking objects as they move around in this video, like this football game, and also going from speech to text and things like that, or even going from one language to another language and so on. The problem with the current wave is that there are ways in which you can fool the system, and it's pretty pathetic in many cases. This panda's image, when it's polluted with a few bits that are not visible to the human eye, some people are intentionally screwing up a real panda image with some of these additional bits. The system comes and says it's a given, and it's saying it with 99.3% confidence. And then when this right-hand side picture is analyzed, the system concludes that a young boy is holding a baseball bat. This, toothbrush is being recognized as a baseball bat. And then there was this famous interactive thing there where the internet trolls caused the AI bot Tay to act offensively, where it said Hitler did nothing wrong. So there are, many situations like this where some companies that put out these sorts of things, Google or Microsoft or whoever, they had to withdraw these things because people were able to make them do things that were not what they were supposed to be doing, or come to conclusions that they shouldn't have come to. And so it's in many such ways that there are problems. And people like, you and me, when we go to a doctor, and the doctor takes lots of information and then feeds all that to a machine learning model, and it comes out and says, yeah, Mohan has cancer, or he will have cancer in the next 3 years. If the doctor just tells me that, and then I ask him, hey, what's the reason for this kind of inference? And he's not able to say, he just says, hey, believe me, this black box is telling me that. We are not going to be happy. And there are other situations where, if you deny somebody a loan, they can sue you if you are unable to justify what was the reason for the denial of the loan or the insurance claim and things like that. So there are many practical situations where you need to be able to explain why certain thing was concluded and so on. So if you look at the Gartner kind of analysts, they've characterized, some of you might not know about this, famous quadrant model that they have, ability to execute in the y-axis and in the x-axis completeness of vision. And interestingly enough, IBM shows up, see, the best position to be in is as close as possible to the top right corner, right? And interestingly enough, Google, while its vision is better than IBM's because they are more to the right, in terms of the vertical axis, they are way below IBM. Databricks is here, Amazon Web Services here, Microsoft is here, and so on. But if you look at some of the big data guys, Cloudera and Alibaba Cloud, they are way in this, left bottom corner. And then there are these, open source libraries and frameworks that are popular. There's some ranking of these things. These are the publicly available ones. TensorFlow, of course, is up there. These are not necessarily rank ordered, by the way. And then there are some of these open source pre-trained models that are available out there for people to play with, as well as use in their systems and so on. They can freely incorporate them into their systems and such. So there's all this attempt at trying to have more reuse of work done by one organization or group of people by other people and things like that. Across the world, for the last few years, different countries have been putting out their AI national strategies. And in the case of the European Union, collectively, many countries have put together their plans in the AI space. Some of them are still developing their strategies. It's a pretty large number if you see here, and you can find a lot more information about all this in the AI index report of Stanford that I mentioned before. So China in particular, for instance, wants to become the world AI leader by 2030. And this was from that meeting that I referred to just before our conference in Shanghai in November. In July, they came up with this plan. They want to turn AI into a 1 trillion yuan industry. They want to become also a driving force in defining ethical norms and standards for AI. And they've got very detailed way in which they're going about accomplishing this by having major plan elements, and the details of this you can find here. They want to make it safe and efficient come up with a safe and efficient AI infrastructure system and drive across industry, academia, and government bodies some of these things. They also want to formulate laws and regulations and ethical norms with respect to these things, set up AI technology standard and intellectual property system, even worry about training people to become more experts in leveraging AI technologies and such things. There are Western people who have gone and analyzed these things to see, is this all actually going to happen, how likely it's going to happen, and whether they're all smoking something or it's actually got some good, facts behind it. And the European Union came out with its plan in July 2018. They want to maximize the impact of investments at EU as well as at the national levels, and they are exchanging best practices. They even have set up, this networks of European AI research excellence centers. They also have these key principles, ethics by design and security by design. Traditionally, Europe has been more into privacy and trans-border data flow and such things, long before the US started focusing on them, even before all this current focus on AI. And so with GDPR also, that's been pushed further. And they're also interested in establishing, reference testing facilities across these countries within the EU. And it's also interesting to look at some of these national strategies to see how different parts of the world choose to focus on different or overlapping kinds of domains, vertical domains like mobility, healthcare, manufacturing, agro-food, and security in the case of European Union. Later, you will see what Singapore and India are focusing on and so on. There are also these organizations that have been established, one called AI Watch, that actually very regularly puts out interesting reports. I highly recommend, even academic types go look at them because they have a lot of valuable information. They track information from across the globe and things like that. And also they have collected a whole bunch of information about past things like this AI history timeline and things like that. And also definitions of AI, preparing for socio-economic changes, and also trying to make sure that there are appropriate ethical and legal frameworks. India has done similar things, but of course, India's ability to invest is not as good as some of the other countries and such. Here, there is focus more on agriculture, health, and education. There are these sorts of documents. They were also fairly early in talking about responsible AI and AI for social good, things like that, right? And there is more also on, for instance, we all get too excited about the algorithmic aspects and things like that, the cutesy things, but actually it's believed that only 10% is this more interesting thing from a research perspective and so on in actually applying AI for various situations. 90% of the work, the preceding work to, actually sticking things into the model and coming out with conclusions and so on, is prepping the data that goes into it. So in fact, this National Association of Software Companies in India has come out with the report which says there is a $1 billion opportunity in driving the AI revolution in the context of the data annotation that goes into feeding these models and training them and so on. The stuff that is before the one that way too many of us have focused on and continue to focus on. That might not actually be the stumbling block. Making that thing faster might not overall make things that much faster. So the Singapore one, given that it's a small island and so on, and also it's a major port for traffic across the globe, especially in the Asian context, they've chosen to focus on intelligent freight planning, seamless and efficient municipal services. It's a single city and also a country, chronic disease prediction and management, personalized education, and also border clearance operations, because there's only one airport in Singapore, right? Commercial airport. And, there's lots of people coming from abroad and so on. So they are also leveraging university like National University of Singapore, where I was for 6 months, by having a center that is part of it called AI Singapore. In the case of USA, DARPA, introduced a $2 billion funding program called AI Next a while ago, 3 years ago. And they are, of course, especially now that China has made its ambitions very clear, are trying to say that they will try to maintain their leadership and do whatever it takes to, be in that top spot, if you like. And so along those lines, they've unleashed a number of things. They're also trying to remove barriers to AI innovation, train an AI-ready workforce, and also, promote an international environment supportive of American AI innovation, embrace trustworthy AI for government services and missions. And in this context, they've the National Science Foundation has funded a number of new nationwide institutes, and typically it's a collection of universities and some national labs and so on. But there is, in each of these cases, primary institution, and that's the one whose name is listed here. And they all focus on slightly different topics, right? Foundations of machine learning, Institute for Student AI Training, next generation food systems, future agricultural resilience, and so on, climate and things like that, okay? There's an interesting conference that I attended, and I want to say a few things about that. This happened earlier this year. Bosch, the German company, had an excellent conference. They have a lot of collaborative things that they do with various universities across the globe, even in IIT Madras and Tsinghua and other places. I'm blanking out now. It's Waterloo or Toronto and some places in Europe. They are focused on many areas, but in particular, they're also into self-driving cars. And their point is that in order to test various potential situations that the car might encounter, trying to do all that in the factory is not practically possible with the amount of resources they can devote. So certain things can be tested in the factory, but by putting instrumentation into the cars, in regular cars even, they can now feed back to the factory a lot more information about how the customers of Bosch are encountering various situations in the real world, and thereby a lot more uncommon scenarios can be encountered. Because in the factory environment, you cannot hope to encounter all the rare situations which still need to be dealt with. properly and safely and so on. So acquiring of field data is crucial, is the point. And there are many challenges, and they talk about all these things. So these are now in a very practical context, rather than your silly social media or purely e-commerce kind of situations that we all might be too excited about. So things like missing explainability, missing causal relationships, which cause safety concerns, huge expenses for data preparation, labeling, and infrastructure, and so on and so on, underutilization of existing domain knowledge. For instance, they said, why should you use a lot of actual data in order for the system to figure out what the speed limit in a certain road is? Instead, if that information is already there, why not directly feed it in? This doesn't have to be inferred. It can be fed as actual data, reference data, things like that. So they talk about why hybrid models are important. In this context, by hybrid, what they mean is physics-based models in combination with data-driven models. And the physics-based models can be very efficient, and causality and explainability and validation and generalization are a lot easier. But data-driven models have their own benefits also. But if you can combine the two, and they talk about actually how to do that in certain specific situations. It turns out I've hidden that slide. So the hidden slides will tell you how to combine the physical model and the data-driven model, sometimes in serial, sometimes in parallel, sometimes in other ways, and so on. And they give you specific use cases where they've found that the effectiveness of radar versus doing a visual analysis of how close you are to the car in front of you are effective at different distances. And so appropriately combining these things gives you better manageability. So the third wave, which is sort of expected to happen in the next some number of years and so on, is the one where contextual adaptation needs to be done. And that's what will result in these metrics that I talked about before becoming much better. It's still not going to be the super duper position, but it will be quite a bit nuanced and so on, not ultra advanced. And that requires that AI systems learn and reason as they encounter new tasks and situations. Natural communication amongst machine and people are needed, and things like that. Okay? So the path to broad AI has to deal with explainability, security, how easily manipulating some bits causes, for instance, a stop sign to be interpreted as go at slow speed, and that can cause accidents and things like that. So the vulnerabilities that exist in some of the machine learning models by feeding slightly modified information when people are intentionally trying to screw up the system need to be worried about. And then the ethics, garbage in, garbage out kind of things that have been talked about, where one system that had been trained with only white people, when it was fed a picture of a black person, it said it's a gorilla. Things like that, which are outrageous, right? And also how to transfer learning from one domain to another domain, how to be able to do inferencing and so on with little amounts of data rather than always expecting to have vast amounts of data. And also developing special machinery in terms of hardware to do things much faster. And I'll say a bit more about that a little later, but Apache TVM is one open source thing that's out there that's trying to make it easier for algorithms to be developed and deployed without having to make the people who develop these algorithms take into account all the weirdnesses of the different hardware platforms and software platforms and so on. So they sort of make it like a compiler where you do the description of your algorithm in a high-level fashion, and then they fine-tune it to make it work efficiently in the context of different hardware platforms and such, regular CPUs to microcontrollers to GPUs and such. So this is an interesting thing also that I welcome you people to look at. The compute demands of AI are growing like crazy. We all have talked about Moore's law, right? Every 18 months, doubling of the number of transistors and such. But here they are saying doubling is happening for certain kinds of workloads. The amount of MIPS required is doubling every 3.5 months. So even if Moore's law were to continue forever, that cannot deal with this kind of massive increases that are being demanded. So that can only be accomplished by doing some innovative things in the hardware and software. And some of the examples that are given are digital AI cores with reduced precision. Turns out a lot of these machine learning algorithms don't require, double precision and this kind of precision, but you can get away with 8 digits, 8 bits or 4 bits and things like that. And also leveraging even analog technology, not just digital. And also some special purpose materials are being developed. Some people who had worked on non-volatile memories are trying to now make use of the circuitry that exists in the memory to do reads and writes, to also do some aggregation computations. So by moving some of these aggregation operations to where the data is in the memory, instead of having to drag the data to the compute elements, you can now exploit parallelism more and reduce bandwidth requirements and also the memory hierarchy. This shows you that kind of thing, the non-volatile memory materials in array cross points to store the weights, for instance, to do some aggregation. This is the PCM technology, phase change memory, where this is being done. And also, in terms of the enterprise, you need to go from narrow to broad AI, and also you have to operationalize AI at scale, where even the AI algorithms might themselves make use of AI in order to handle much larger workloads and things like that, or automating the life cycle. This is in some ways like database systems internals making use of AI in order to make the database systems be more self-managing, figure out when to reorganize the data, when to create indexes, when to remove the existing indexes because they're not being used as well, or leveraging AI technology to fine-tune the cost model. As you run the system, let's say you move a system from one kind of hardware platform to another, you don't have to pre-configure the cost models to be aware of what model of the processor it's running on and so on. It can be figured out by doing some test executions, things of that nature. And also going from where we are today to the future requires, developments to happen in the full stack, all the way from the top application area to algorithms to compute to the data, going from static data to dynamic data, traditional infrastructure to hybrid infrastructure, these novel devices and materials, for instance, going from implicit memory to implicit plus explicit memory, on and on. I'll let you go look at some of these things on your own. This topic I already covered, how to leverage AI for AI. One important thing that a lot of you might not be aware of, as somewhat of a follow-on to the Jeopardy competition system that was developed, much more recently, IBM had this project called Debater. This was to make the system get involved in speech and debate competitions and deal with the best human debaters out there. And this is much more sophisticated than what was done in the simple question answering kind of situation that the Jeopardy competition involved, where the system didn't even have live access to the internet. All the information that was potentially useful in the particular context in which the questions were going to come up were pre-loaded into the Jeopardy system. But here, there is live access, and it also involves the opening speech by both parties, meaning the human versus the system. The system can be asked to take the pro-proposition position or the counter-proposition position. So both make speeches. Here they have to really, the system has to really understand the speech. Whereas in Jeopardy, the question was typed into the system. Whereas here, it has to understand, and then it has to come up with counter arguments to what the other person said and formulate these counter arguments in human language form So there's a lot more sophistication that's involved. And a lot of these things just cannot be done with purely, deep learning kind of models. So this is just one particular situation that I have in mind. But you can find a lot more information about this whole problem in this Nature cover story called the Silicon Soapbox that came out a few months ago. Okay, AI for data management. I think I'm pretty much done now. So we are going to go from this inside circle all the way to the out, and that requires a lot more things to be dealt with that go far beyond polishing the round ball kind of thing that many of us might be engaged in, where we are trying to marginally improve performance and this and that without worrying about big picture things like, am I solving a real world problem or am I just barking up the wrong tree and things like that. If you want to track my activities in various areas, I regularly post my presentations and videos and so on in various social media places. Here are the links to those. Thank you so much.
Great. Thank you very much, Mohan. It has been a very interesting talk. So
thank you.
Yeah, thank you. And I think it would be great if we can open for the session for questions and perhaps discussion. So the way to proceed is you can raise your hand. I'll try to be careful not to miss somebody that wants to raise a question. So, there is this, there is a way in Zoom to raise hand or just unmute the microphone. Perhaps, so is there any question? I don't see any question right now, but I can start perhaps with a quick question.
Sure.
So, the pace of research in AI has been remarkable, and you pointed out so many impressive aspects. But I think that it's still, and you actually addressed that, we still need to bridge the gap between machine and human level intelligence. And,
right.
There are different issues like an intuitive way of understanding the physical world, efficient, rapid learning, transfer of knowledge and generalization. You did address a few of these aspects. So I was wondering, what do you think? And also, actually, you point out another one, a very important, the ability to reason relationally. For example, I guess, solve visual analogies, etc. So I was wondering, in this context of, let's say, human-like AI, which do you think that they are the most important research challenges or directions that we should focus on?
So I would suggest that specifically that last thing I talked about, which is the debater project, they've had to deal with that in a big way, in the sense that because the system is listening to somebody's arguments, first of all, the system has to be able to even figure out, they're not always necessarily going to be talking in a grammatically correct way and all that, right? So there will be a lot of things that are more human-like in that case than reading a textbook or a storybook and so on that has been properly edited and things like that. And also in formulating the response, it has to also be like, the better way of saying this is, if you look at Google Translate, you take something in Greek and then you see what it produces as the English version of it. You will see it looks funny in many ways and so on, right? So, so the things that normally you and I do in whatever language we are good at, how do you now capture that, represent it in a form that it can then be applied by these systems when they are going about trying to, essentially try to pass the Turing test, for instance, right? Which is, can you fool somebody that's interacting with the system to think that the person is actually interacting with a human rather than with a machine? And that does require that, it in some ways relates to how a lot of these call center people in India get trained to behave like Americans in responding to complaints from customers in America. They even give them Western sounding names, but also they educate them about football and this and that, that some small chit chat that people do even while they are whining about their TV not working or this or that, their phone not working. They engage in small talk, right? So there are a lot of cultural aspects also that go with all that. And so some of these training entities in India coach these people on what phrases are popular and how, the meaning also differs from one part of the world to another, even though they're all, let's say, speaking in English. So those are the sorts of things that I would say that in a sense, characterize what it means to behave like human, and also the empathy factor and things like that, right? You don't just in a mechanical way put out information. If somebody asks a question, you don't just give the answer. In some ways, this is also culturally very different, right? And sometimes some of us complain after having gotten used to going to supermarkets in the US, and the clerk at the checkout counter does some, oh, how is your day going, blah, blah, blah kind of discussion. Whereas you go to, let's say, Singapore, they're like business-like. Hey, this is the money, pay it and get lost. We want to increase throughput or whatever. I mean, we're not going to engage in some, niceties and things like that. So it has a lot to do with culture too, in that sense. What different people, in some sense, this requires some profiling too. Older person versus younger person, who you are dealing with, and so on and so on. So I don't know whether that's a good.
Yeah. I think that you actually address very clearly the demand, the need for having interdisciplinary research, because there is the cognition, there is the psychology, this sociology, apart from computer science and mathematics.
Right. In fact, if you look at the full presentation, I actually decided I'll go look at the first IJCAI conference, the International Joint Conference on AI, and look at what the session topics were, and then looked at one of the more recent ones. I think I looked at the 2019 one or something, to see what is going on there versus what you find in normal research kind of discussions at universities or research centers. I mean, obviously these are research people going to these conferences, but still, there is still a lot of discussions about knowledge representation and so on. But if you sort of look at the buzz and such, it's mostly these days deep learning, right? But at the conference level, there are certain things that have stayed constant from the first IJCAI to the latest IJCAI. But there are certain other topics that have come up. In particular, what you just said, a lot more domain-specific kinds of sessions. Combination of AI for this, AI for that, where that and this are different domains, like music versus, geography versus something else, chemistry or process sector versus transportation sector and things like that, or healthcare. Of course, the conference itself has become huge, number of sessions and so on. But also the themes are in certain ways changed. Games, for example, leveraging AI for games. So all these computer games where apparently a lot of money is involved. People bet on some of these computer. I don't go anywhere near those things, so I'm not intuitively knowledgeable about those things. So, okay, thank you.
All right, thank you. Dimitris has also a question. Dimitris,
sure.
Please go ahead.
Thanks. Mohan, thank you very much for the talk. It's great
You're
talk.
welcome.
So can I ask you, so it seems like machine learning and deep learning is actually taking over everything now these days, right?
Right.
And it's this black box and everybody's worried. I mean, like you said, do you think there is going to be a backlash and people actually are going to say, okay, we need to worry, how these things are being used? I mean, people are worrying in a research perspective. Yeah. But is there a public?
I believe so. In fact, this is one of the reasons why I gave the references to some of the articles at the very beginning. They are very interesting. Some very detailed articles have been written in the MIT Technology Review and Fast Company that go into some of these things, the tricky issues. even people like Jeff Dean are quoted there or pointed out as this Black woman used to work for him. And so they are, and like I said, LaCoon is arguing with the editor, with the reporter in public about, hey, she's not good or this or that. He's not, I mean, it's going beyond just the technical aspects or the factual matters that are being talked about. A lot of, pussyfooting is being done around this because it involves a lot of money and such things also, right? It's not anymore purely technical thing. There's a lot of people thing involved also, societal kinds of concerns as opposed to individual companies' profits and other motives, and also individuals within those companies, their own reputation, this, that, right? So it's quite a messy state of affairs right now.
Yeah, I think also you said there that the current Congress is talking about AI a lot. I mean, it's how you frame this, because you can always frame it at the right level, and if you put it at a different level, a different person will get the benefit. But how do you decide? I mean, again,
okay.
I mean,
I think I know what you are getting at. If you are aware, I didn't even bring it up here. There is all this congressional testimony that has been held, especially with those big guys, right? Apple, Google, Microsoft, Facebook, and so on, Amazon, which is to do with, are these guys too powerful now? Monopolistic kind of practices and things like that. So should they be broken up? Having been an IBMer for so long before I came to IBM 40 years ago, there was this antitrust suit against IBM, even before I came to America, which resulted in IBM having to sell away what was called the Service Bureau business. Guess what? That was the age-old cloud, where other companies will use IBM machines, rent IBM machines to do some specific processing for a short time. The IBM had to sell it to CDC. And because they said IBM should get out of that business as a way of somewhat reducing its monopolistic position. And also at the same time, IBM became very nervous about interacting with universities because they were afraid that the consent decree that was agreed to with the US courts and the US government might prevent them from influencing these kids too early in their lives, as a way of making sure that when they get out of college and all that, that they would wind up buying IBM machines because they got used to. And that's when DEC, for instance, became very popular at the universities, Digital Equipment Corporation. It was a long time later that IBM finally started interacting with universities and giving them machines and so on. So there are many such things that are also at play here. What motivates people? If you read that article about this guy who was put in charge of fake news, there's all this concern, if you put too many restrictions, the number of users of the growth rate of, Facebook users might come down, and that might have implications on whether they are continuing to make more money. It's far beyond, what you and I as researchers or techies might worry about in writing our papers and getting our papers published and such.
Yeah. Things. And I have another question. I mean, what do you think about, I mean, as you said, in the end, you need data, right? I mean, everything. And data is it's both very precious, but it's also very too many right now. And then you have this problem. So what do you think there? I mean, what are the,
but keep in mind that it's not like everywhere you have this data. This is the major point I want to make, that we are all too focused on this big data and so on, and we pretend as if all this concept of petabyte databases or whatever is everywhere. That's not true. The average database size is not anywhere near what you and I get, excited about just because we pay attention to the e-commerce giants or the social media giants. But in the average enterprise, B2B or government to people and so on, there isn't as much data as you have when all your clicks are being followed and things like that in the social media companies, right? You have 1 billion users and so on. So in that sense, it's not so common at all. And that's the bigger point I'm making, that if you want to leverage AI in these other spaces outside of this currently popular spaces, which is where there may be a lot more things that need to be done, because that's where much larger number of organizations than these few big guys like Facebook and LinkedIn and such need to be able to leverage AI, and hence the need for well-trained manpower to leverage statistical methods, whatever it is, right? Whereas these big companies, they have so much money, they can hire the best and the brightest of the world and so on. But the average IT company or some domain company, chemical plant or whatever, cannot afford to spend as much money to hire the guy with the PhD from Stanford or this or that, right? So in many such ways, you guys as professors and such that train the world's next set of people that go out there and do things have even more work to do, in the sense of not just focus on these giants and what they perceive or they propagate as what the world needs. They have their ulterior motive, whatever you want to call it, as the reason for them wanting you to focus only on them and producing the future employees of such companies. But the world also needs other people that need to work in these other kinds of organizations, whether they are government or private industry or NGOs and things like that. So in many such ways, and also the other fact is that if people are not careful, they wind up focusing only on, let's say, the white people or certain kind of people, and hence whatever they develop, how much money they might spend, has narrower applicability. This is the garbage in, garbage out problem, right? And there are many examples of that have been talked about. And so to that extent, also in a kind of socialistic way or a ethical way, fairness way, you do need to think about other geographies. So this has been my complaint also in the traditional way in which Silicon Valley companies have worked. Oh, I'll first develop my thing only for English language. As if, right? But then a lot of times they don't do a proper job when they start supporting other things. By the way, a similar thing applies to China too. All these big Chinese companies are focused only on the Chinese market, and they have a tougher time when they are trying to go abroad. Even their manuals and the comments in the code and so on, they're not in anything other than Chinese. And even their Mandarin versus Cantonese and all that is an issue.
Can I ask you a follow-up question, kind
Sure.
of like related to the training?
Yeah.
So there are many universities that they are trying to develop AI-based or AI-driven programs, graduate level programs mostly. Mm-hmm. So I was wondering if you had the power to develop your own, let's say, excellent program in AI, what are the courses and the emphasis that you are going to put on, to focus on?
Well, so one thing I'll say is that don't only focus on machine learning, focus on knowledge representation and all these other things that also are important. So to that extent, don't do this go with the flow or whatever kind of thing, the sheep mentality. I've even in my own research work, this Aries technology I worked on when it was no longer fashionable for people to work on concurrency and recovery. Everybody else was working on whatever XML, this, that, but that's because they all assumed conveniently that all the problems needed to be solved had been solved. So this is why I'm saying it's important for people to look into the past also to see how things used to be done, what were successful, what were not successful then, and what are the shortcomings of the current thing. Don't only look at narrow domains like recommendation systems and such. Look at other application areas and figure out for those application areas what are the important things to think about. And also this business of like combining these physics-based models with statistics-based model or data-driven models. things of this nature. So some of that stuff the Bosch guys came up with because they actually looked at certain domains in manufacturing. Bosch is a big time components manufacturer and so on, right? And also in this new area that they are getting into, which I didn't even know they were into, which is the self-driven cars. Just like Baidu got into self-driven cars, even though they were originally, Baidu is like the, I guess the Google of China, if I remember right, yeah. Like WeChat is like Facebook of China, right? So as you explore in a more serious way, rather than just in a paper writing way, certain topics and actually try to implement something and put it to practical use and so on, is when you will get these insights as to what works, what doesn't work, how much is the work involved in actually prepping the data. So that's another thing that is important, the whole life cycle of data that goes into building these models and so on. How much focus is there on that? It might not be sexy, but it's useful, important things to be taken into account and worked on. If you can speed up that thing, the initial stuff, labeling the data and all that, that can improve the overall time from when you want to solve a problem to when you actually have something that, at least in a certain way, solves a problem. You can shorten that time duration.
Right. I know that in the list of participants, there are some undergrad students. So I'm going to perhaps ask you to, if possible, to pick, let's say, the 5 most important, let's say, courses or type of knowledge that you believe that it is very important in order to build a very good, a very solid AI program. I mean, if yeah, I don't want to press you too much, but you know.
I don't know if I haven't looked at enough the current courses and so on that are at universities. Mm-hmm. In some ways, I'll say the following, which might give you some idea. Mm-hmm. I was quite annoyed when my son went to Berkeley, mm-hmm. and was doing a double major in computer science and cognitive science. I said, how can Berkeley let you graduate with a bachelor's in computer science without requiring that you do a course in operating systems, a course in programming languages, a course in database systems, and one in computer architecture? I felt for any computer science worth his or her salt, these things are fundamental things. But like you are asking, there is this struggle between to try to make somebody useful from the time they get out of the college. What is it that you now teach them? See, there's all this thing about, in fact, there's a lot of discussion going on, by the way, in Clubhouse and places like that these days, in the US especially. Is a college degree important at all? Why can't people just be trained to have certain skills which are cheaper and shorter duration? You know, in India, we have these technical institutes, they call them, Indian Technical Institute or something, which are like the community colleges in the US, right? Which don't even give you a degree. They give this AB, 2-year or whatever thingy. The problem with some of those too narrowly focused things is that people don't learn to learn. They learn only one skill. They are not able to then, when the time comes and they have to shift gears, more easily go into another area because they are so narrowly focused. So in that sense, I would say, do teach. So this has come up, by the way, in the context of all this big data, NoSQL and all that. Should we still be teaching SQL at all to people in database courses? Should we even teach the fundamentals of data management and query processing and so on, or just teach them only the usage related things rather than the innards of database systems? But I think it's important for people to learn not just what's currently popular and what they can start doing right away, because these languages keep changing and so on, right? So in that sense also, I said compilers and such are important. Don't tell me compiler optimization is who cares and things like that, because you learn a lot about the machine as well as the software that runs on top, register optimization, all that, right? Memory optimization. So you get to appreciate better, because you are forced to think about the machine in which your thing will be running. Abstracting away too much is not good, because then you are in la la land. So when people went from regular computers to, what do you call them? Controllers, itsy bitsy controllers and so on, or in the more recent context with mobile devices or IoTs, suddenly things that they took for granted, vast amounts of memory and so on, vast compute power, is no longer true. They have to make do with also connectivity that's not high bandwidth, not continuous connectivity, intermittent and such. So those are the sorts of things that I would say you should focus on, not just go too deep on any one thing, and not give them a bigger picture, a broad-based learning. So in that sense, I would say in the AI context, don't just go off the deep end only on various machine learning algorithms and such, but also tell them about some of the other things I mentioned, which have to do with knowledge representation, combining other techniques with machine learning to solve the bigger problem, worry about where the data is coming from, how trustworthy it is. So all those things about ethics and fairness and such also, even at the undergrad level, I think it's important to at least give the minimal amount of exposure.
Thank you very much. Thanks.
Welcome.
Other questions?
Somebody typed something. I don't know what that is. I haven't looked at it.
Well, I haven't seen a written question here, or
in the chat, I see the name is in Greek, so I can't read the name of the person, but I would like to ask a question. In the case of self-driving cars, for example, is it better to set up the environment, placing stop signs and speed limits where we choose and then tell the agents to obey the strictures, or is it better to place the agents in an environment without rules and let them learn and later work together and set speed limits and rules? In the second case, we might get optimal results where, for example, the cars both reach the destination faster and more safely than in the first scenario. Okay, this is kind of an interesting question. So the person is saying, should these self-driving cars go around the roads and so on? And based on, I'm not quite sure how they've been programmed, somehow figure out what the ideal speed limit is and things like that, instead of ahead of time setting the speed limits and such. First of all, we need to understand that for the long time to come, we will still have a mix of self-driving cars and people-driven cars on the roads. So the rules have to be explicitly specified for the people that are driving the cars themselves to obey, right? So the way you are referring to it. So Maria, are you saying you're not able to see this question in the chat?
Yes, probably this is a question to you. I haven't seen this.
Oh, I see. You are saying he directed it to me.
Yeah. So I know that there are a few people raising their hand now.
Okay.
I see them, but I haven't received the question that you just.
Okay, I know what you mean, because this person sent it. I'll just put it in the.
Yeah, or perhaps he can unmute the microphone and.
Yeah. So anyway, my point is, I think with the mix of people, pedestrians, and cyclists and others being on the road at the same time as the self-driving cars, and also people-driven cars, a mix of all this happening, which is the case, by the way, with city streets, compared to, for instance, in the good old days project that the US DARPA guys funded, which is the one where I said Carnegie Mellon guys won, and all that. That was in highways where it was a much more controlled environment. So in the context of city streets, what this person is suggesting is like not possible at this stage, at least. So you do need to program in the stop signs, or at least the speed limit, because you don't want to discover the speed limit based on training data and all that, right? The maximum allowed limit, the legal limits and such. And so it's quite a lot of technologies that are involved in this. So the talk that was given in that Bosch conference was very interesting. It was by a woman who used to lead the team in University of Toronto or Waterloo. She's still there as a faculty member, but she was also part of the team in Uber, I think, that was into self-driving cars. And then Uber decided to shove that thing into a separate company jointly with somebody else. But this particular team that this lady led was not made part of this new company. Okay, so she had just gone through that transition, and she continues to be a faculty member. And she gave this excellent talk on what it takes to, do self-driving cars. What are all the realistic kind of things that you need to think about? And so it's in this context that some of these sorts of things were mentioned. So you said somebody else wants to ask?
Yes, Emmanuel has raised his hand.
Okay.
So Emmanuel, please go ahead.
Hello there, can you hear me?
Yes, very well.
Sure.
Let me first thank you for taking time to give us this presentation and for the great content of the talk. And when someone is is talking about self-driving cars, you think of a certain company, right?
Yeah.
Mostly. And the person leading that company has issued some warnings about how the AI can get out of control, and at some point human ideas will be replaced by ideas produced by the networks and stuff. And he's been releasing videos about that. And since that I'm not qualified to produce a good conclusion on my own, yes, because I haven't got the knowledge to qualify for answering such a question, and I would like to know your opinion about this. On this.
Well, I first of all, I don't know who this person is and what this person is claiming, but maybe you can type the name of the person and I can offline go look at this thing. But in general, yeah, I mean, there is a lot of these concerns, right? That and that was one of the early on points, in a sense. If you start leveraging AI for warfare and things like that, it all is going to get even more messed up, right? With all this hacking and such that are going on. It's also in some sense like chemical bombs and things like that, right? If people begin to leverage, in a sense similar to what the US did with the Iranian nuclear reactor thingy, where I guess it was the US and Israel jointly went and messed up that thing by hacking the code that runs in that whatever it's called, the uranium, what's the word? Not concentrator, something, whatever. The thing that produces weapons grade uranium. So yeah.
Uranium fission.
Yeah. I mean, but there is a process that they called, I'm not getting that particular name, which is producing this ingredient. There's a name. Anyway, it's not refining, but something like refining. So there are, yeah, it is possible that if you let loose AI and, it takes over in a certain sense systems, and also if you make robots go crazy, you could wind up messing up, regular kind of life and such. But it's all in our hands as citizens and as responsible people in government and so on. But it could still, of course, get exploited in those bad ways when it comes to dealing with your enemy and things like that. And that's why I was bringing up the examples of, sometimes even countries like America going and doing things in other countries where they think there are bad people and they justify it based on their own, claims about being morally superior or whatever, right? But similar things are now happening with all this hacking with Russia and China and things like that, right? So, so there is no, nothing that I can say that is going to change anything, but we all have to be responsible. That's why there is this concept of responsible AI. And in fact, IBM was very early on in this business of, coming out with a manifesto, I think it's called, that listed what it means to be responsible AI. For example, IBM decided sometime after that manifesto was put out that it won't engage anymore in facial recognition technology development and selling and so on, because it felt.
I'm sorry, but what I wanted to mainly say is that, okay, we have all these things like AI in modern warfare is applied right now because we have self-driven drones who kill people, and that's not mainly our problem. Putting AI in warfare is a different matter, in my opinion. What I wanted to say, because that particular person, Elon Musk, was saying that there is a chance, in his opinion at least, without me justifying it or knowing if he's right or wrong, right? He's saying that maybe if AI gets out of control or anything, maybe like human ideas will be, they will be replaced, because the thought process will be replaced by the AI, which maybe.
Okay, that is all hype. Okay, I didn't realize you were referring to Elon Musk. Okay, he's a bit of a crazy dude, he keeps doing some dumb stuff also with respect to blockchain and all that. So in fact, even yesterday I was bad-mouthing him in a conversation in the summer school that I'm at. And even tomorrow I might say something when I give my blockchain talk. Tomorrow at 9 a.m. to 10 a.m. If any of you are interested, you can also log into this Raise Summer School, which is being streamed. No, I mean, yeah, you can always paint a picture of some of those sorts of things, but talking about taking over the brain and this and that and thought process and all that is, at this point, at least in my opinion, more like science fiction. But it's still up to us as societal people to decide where to deploy these sorts of AI things. Even if they get that power at some point, we can choose not to. This again has to do with, what do you use certain machines today for? Even the drone example you gave, if we use it in warfare and do bad things, we are making a conscious decision to do that. We could choose not to do it, right? Just like IBM got out of this facial recognition business, it made a policy decision. So it's up to us, even if systems become capable to do all sorts of stuff. It's not like they themselves are going to go do all this crazy stuff. I mean, yeah, it's after all programmed things. If you build these things and you don't, put them in some warehouse or whatever and lock them up, they could wander the streets and these robots could do all sorts of crazy things. So I won't take his worst case scenario kind of painting that he's doing as something that is a fait accompli, that it will definitely come about. I don't know whether I answered your question, but that's all I have to say.
Well, I pretty much understand where you're coming from on the matter, and okay, you've completely covered me. Also, let me thank you for your answer and your time answering me. And I would like to ask you, so tomorrow for the blockchain talk, is it like Eastern European time, 9 a.m.?
Oh yeah, I'm here in Crete, right? So I'm going to be in this hotel, and it's an in-person event that's going on, but it's also being streamed. So it will be 9 a.m. to 10 a.m. Eastern European time. And where are you based?
Well, I'm originated from Crete as well, but I wasn't aware of your convention, or else I wouldn't leave. Right now I'm at Corfu. I'm studying here in the Informatics University.
Okay, so if you go to my social media accounts, and I showed you in my last slide, I can put that slide back if, am I still sharing? Okay. Okay, if I go to the last slide, control, yeah. Are you guys able to see this?
Yes, we can. And then there is another question from Yannis Samardinos after this question.
Oh, okay. Yeah, anyway, so if you go look at my Facebook account, anyone can look at it, or LinkedIn and all that, you'll see posts over there which give you the link to the RAISE Summer School, RAIS, blank Summer School, and you'll see the Zoom link over there for the talk tomorrow.
Thank you very much. I'm looking forward to your tomorrow's talk as well.
Thank you.
Thank you very much.
Appreciate it. Yeah, sure.
Yannis Samardinos also wants to ask a question. You
Sure.
can raise your hand. There is here in the reactions a way to raise your hand so that I can give you the.
All right, there you go.
Or unmute the microphone.
Make it formal. Okay. First of all, let me be grateful to Maria for inviting you and organizing this, and also you, of course, like for taking the time for this excellent talk. I thoroughly enjoyed it, and reinforced a lot of my ideas too. AI is not deep learning, and things that we're trying to instill to our students. Yes. In any case, I would like to hear your thoughts on the following. Like, I see parallels between developing like aviation and developing AI. So we have like planes, and we have like they go supersonic and now hypersonic, and so forth. But they're nowhere near birds. The capabilities of birds, like finding food for themselves, or like fixing like healing, self-healing, and many other things, and surviving in the wild. And I see like this parallel in the way we produce AI. So we have machines that learn like with millions of like, let's say, genetic markers and things like that, much better than humans, but they're not, of course, like, they're lacking this generality, adaptability, explainability, and all the things that you mentioned. I'm thinking like the only way, I don't think we're probably not smart enough to develop true AI, at least not in the foreseeable future. And I'm thinking the only way to do that is to actually evolve it. Evolve it, yes, somehow, like maybe through evolutionary programming, or this type of means.
Okay.
However, like I'm checking the literature, and we're still in the infancy of that. Like they can evolve like some basic algorithms, and they're very innovative for let's say sorting, but that's the level we've gone. So I'd like to hear your thoughts, like on the statement: are we smart enough to create general AI soon?
I don't think it's going to happen soon. I mean, because we still have lots more to go in terms of doing the things where some of those counter examples were given, right? The panda being recognized as given or whatever, and things like that. So so there's a lot more nearer term things that need to be accomplished. And also, this one size fits all kind of attitude that some people have, that, deep learning can do everything, is more wishful thinking. So in that sense, even recognizing the shortcomings of some of these things and recognizing better what are the problems that need to be solved in a domain specific way and things like that. That's where I think the more immediate focus should be. And in the longer term, and again, there'll always be some people who will do the fringe work or the much more futuristic work. And then there'll be others who will be doing more applied work. I mean, in our lab, we've always had those mix of people, right? People who move individual atoms without knowing, what's the benefit of being able to control movement at one atom at a stage, which was done in my lab, right? Using the scanning tunneling microscope that was developed in Zurich, for which a couple of IBMers got Nobel Prize in physics. So in that sense, I would say, yeah, I mean, at some point, there will be some amount of self-learning and things like that that will come about. But I think it's too far into the future. And
so do we need to evolve it? Is that the solution?
I mean, there have been always these sorts of in distributed systems. People have talked about, what do they call them? These set of algorithms that are supposed to be like birds and such. I'm forgetting the name that.
But there's AI life.
Neuromorphic. Are you referring to neuromorphic or bio-inspired? Or?
No, I was trying to give an analogy with respect to some distributed systems algorithms where they talk about
emerging complex systems, emergent behavior,
Yeah, but they give an analogy like Yannis said about birds and such. There is this analogy with I forget now, swarms or something, where you flood the network with messages and they sort of route themselves and so on. But I think, it's still too early, in my opinion, to figure out how that's going to come about, whether it will be evolution or some other thing. I'm not. It's below my pay grade. I mean, it's above my pay grade too. Because like I said at the very beginning, I'm not an expert or anything by any means. I'll say a bit more confidently things about database area, but this AI area, I've been more of a collector of information and observing and remembering stuff from decades ago and so on, and going to, enough number of events to be a pain in the butt of some people by asking hard questions and things like that. But in general, I'm the kind of guy who, even in the big data area and things like that, or NoSQL, being hype versus reality kind of person that tries to inform people. Don't take everything that's flashy as the only thing that matters, or that it completely covers what needs to be done and things like that. So I felt in this AI space also, as I was asked to give a talk somewhere, and I started digging more into it, that it'll be useful at times to make somebody like me with a different kind of lens or whatever come and do a bit of preaching, if you like.
Well, that's very useful. That's very useful. There's so much hype. And so it's so difficult to distinguish between like the noise and the signal in the field.
Exactly. That's the sort of thing.
Yeah. And it has hurt the field tremendously in the past.
And in a similar sense, in the blockchain arena, there's way too much hype with all this permissionless Bitcoin, Ethereum, and all this nonsense. And there is the permissioned blockchains. And I was flabbergasted that, such a large fraction of people across the globe, including Elon Musk, have bought into all this hype about, out of thin air, you create money and you think you know what you're doing. And, people with no background in economics or money supply and all this kind of societal kinds of things, goods and services, they just go off the deep end, and you and I as techies think that we know anything at all about all this, and come up with what's in the computer, and we call it money. And
well, on that I will disagree, but that's a discussion for some drinks.
So there is another question.
Sure.
Anyway, thank you. I'll
sure.
let you jump to the next one.
Okay.
So I'm going to read it. Simon Platiotis doesn't have a microphone, cannot use his microphone right now. So he's asking if you believe that we'll be able to deal with the efficiency power consumption issue, or it will hold us back in the future.
Okay, so this is an interesting one. As I said, in this whole requirement with respect to certain kinds of workloads in AI, the fact that some set of people have come up with this projection that every 3.5 months there's doubling of the requirement. First of all, caveat, again, don't think just because certain workloads require that's something that universal and that applies to every AI problem that's out there. Some of these things are workloads that have been defined just for the heck of benchmarking and so on. They might or might not have real world implications that have really, societal good and so on. So I see some of these recommendation systems as nice to have, but not required. Whether Netflix tells you after you watch one movie, these are the other movies you should be watching, and they are willing to spend incredible amounts of money to come up with that recommendation. Is that really of some fundamental value in society? Are those the most important kinds of problems to be solved? So you have to ask that question also. Just because some of these benchmarks have been defined, this doesn't mean that they necessarily have some real world implications that are fundamental in some nature for society to continue and such. So, but having said that, there are many activities that are going on. Like I said, reduced precision way of doing the computations, which are good enough, and hence you can have more processing elements in the same amount of, let's say, chip real estate, as well as even combining analog with digital. So at least the projections that have been made, and I didn't get to share those slides, they are in the deck, how much improvement is made by going from 8-bit to 4-bit to 2-bit and so on. The IBM people who know better in this, it's not just IBM, by the way, it's a pre-competitive consortium that's out there in Albany, New York, where people used to work on chip technologies before traditional computation and so on, which was pre-competitive. A bunch of companies get together, thereby sharing the costs involved in developing new chips and so on, with some money being invested by the state of New York. They are the ones who have been working on this. And it's also, I believe, part of the MIT IBM Joint AI Research Center. That I'm not 100% sure whether the hardware part is part of that thing. So this is where they think they will have quite a bit of progress in improving the performance and such. That's it. You are muted, Maria. You are muted.
Yes, yes. So thank you very much for the answer. And thank you very, very much for this excellent presentation and the very thoughtful answers. It is a real pleasure to have you here, and we very much appreciate it. So
thank you, Maria, for all your work and
no, it was a pleasure. Thank you.
Enjoyed it. And I think you've already mentioned that since it's being recorded, it will be posted the next some number of days, right?
Yes, definitely. Typically, we upload it at YouTube, and so I'll provide the link both
Wonderful.
to you and also to the students. And
sure, thank you. If you can send me the list of attendees, that will also be nice. I don't know whether that gets captured.
I think so. Yes, I do have the list, absolutely. And actually, also my colleague Yannis Samardinos has raised the hand. I'm not sure. Yannis, would you like to add something, or it was from the previous question?
That's for the previous question. No.
Okay.
Okay. Thank you.
Okay, great. So thank you
all of you. Have a great time and stay safe.
You too. Safe trip back home. And thank you all for the participation. We very much appreciate that. Bye. Bye.
Bye. Thank you very much.
Yeah.